Now let us discuss some properties of Laplace transform. And all the properties are similar to those of Fourier transform. So I am not going to derive any of the properties. I will just state the property and I will explain what happens to the ROC because that is important. So the first property is the linearity property. We have already used that property. If x1t Fourier Laplace transform is x1s and x2t, and if I am denoting the ROC of this divided by R1, that is the ROC of this x1s, and this is R2. By the way, what is ROC? ROC is the, if you are given an expression for this Laplace transform, ROC is the region where that expression is valid. Okay, outside that region, that expression is not valid. Now, what about what will happen if we multiply with a constant a? So it is straightforward. What will happen to the ROC? Will it change?
No, sir.
No. What is the reason? Because the Laplace transform of the signal e to the power, it is minus infinity to infinity mod xt e to the power minus sigma t dt. This should be finite. If you want to find the Laplace transform at some point, take the real part of that as, this is a complex variable, some point as, take the real part, then this condition here, sigma is the real part of this. This condition must be satisfied. Now, if you multiply with a constant, what is the condition? If this is finite, what about this? That will also be finite, right? It is mod a into this one. If a is finite, can we say that the region of convergence will remain the same? What is region of convergence? If you consider a signal x1t, if you want to find the Laplace transform at some point, what is the condition for existence of Laplace transform at that point in the S-plane? The signal. Because the Laplace transform at this point is the Fourier transform of what? Fourier transform of? Is it x1t into e to the power minus sigma t into e to the power minus j omega t, isn't it? It is the Fourier transform of x1t into e to the power minus sigma t. And the condition is that this must be absolutely integrable. Now, if you multiply with a constant, it is straightforward. Please verify that this ROC will remain the same. The values of s for which this integral converges, that will remain the same, even if you multiply with a constant. Okay? If it is a is of finite value, that will remain the same. So the linearity property says that a1 x1t plus a2 x2t. What will be the Laplace transform? Is it a1 x1s plus a2 x2s? This is the linearity property. We have already used this by the previous example we discussed. Like sum of a right-sided signal and left-sided signal. There we use the linearity property. Okay. Now, can you tell me if R is the ROC of this? Let's say this is xt. That is a linear combination of x1t and x2t, and its Laplace transform is x of s. Linearity property says that this x of s is a1 x1s plus a2 x2s. And let me denote the ROC by R. Can you tell me what is the relation between the ROC, these three? What is the relation between these three?
R1 intersection R2.
R is equal to R1 intersection R2. Is it that? Because this expression is valid in this region R1 and this one is valid in this region. So sum of these two, that is valid when both these expressions are valid, isn't it? Is it that? R1 intersection R2?
Yes, sir.
Okay. But there is a problem there that will be okay, let us consider an example. We are given that this is an example from Oppenheim, x1t minus x2t. Okay, xt is x1t minus x2t. We are given the Laplace transform of these signals. X1s is 1 upon s plus 1 and its ROC is real part of s greater than minus 1. Okay, it is a right-sided signal. It is e to the power minus t ut, isn't it? That one. And x2s is, that is the Laplace transform of the signal x2t, that is given as 1 upon s plus 1 into s plus 2. And its ROC is given as real part of s greater than minus 2. This is given. Laplace transform of this given. Now what is x of s using the linearity property? It is x1s minus, because signal x1t minus x2t, so using linearity property, its Laplace transform is x1s minus x2s. So this is 1 upon s plus 1 minus 1 upon s plus 2. Okay. Now one thing, we are given that this is the ROC. Then what is the nature of this signal x1t? Is it a right-sided signal, left-sided signal, two-sided? What is x1t?
Right-sided.
It is a right-sided signal. What about x2t?
Right-sided.
Right-sided. Then what about xt? Sum of the difference between these two signals, that is also, if you subtract a the right-sided signal from another right-sided signal, you always get what? Right-sided signal or something else. It can be a finite, sometimes it can be a finite duration signal also, isn't it? Is it?
Yes, sir.
It can be a finite duration signal also, but it cannot be a left-sided signal anyway. Is it? Do you agree with that?
Yes, sir.
It can be a right-sided signal or a finite duration signal. Okay. Now let's see what happens here. This is s plus 1 into s plus 2. Can we simplify this?
So s plus 2, 1 upon s plus 2.
It is 1 upon s plus 2. Is it a finite? What is the nature of this signal? Can it be a finite duration signal? Can it be a finite duration signal?
No, sir.
No. It must be what? It must be a right-sided signal. Then what is the possible ROC? It must be a right-sided signal. What is the possible ROC then? There is one pole at minus 2, so the ROC must be real part of s greater than minus 2. Is it the intersection of these two? This one is real
sir.
part of s greater than minus 1. The other one is real part of s greater than minus 2. The intersection of these is, these two is in real part of s minus 1, greater than minus 1, but this is not the intersection. So the linearity property is that it is not R equals R1 intersection this one. This is the property. It can be a superset also. And tell me why it is happening. Remember, if the Laplace transform is a rational function, the shape of the ROC is determined by what? Determined by the poles of that function. By the poles of that function, isn't it? So if you consider these two separately, there is a pole at, in this case, there is a pole at 1, minus 1, here also minus 1, minus 2. Now what will happen when you subtract this? This is the expression s plus 1 divided by s plus 1 into s plus 2. Is it? That is how you get 1 upon s plus 2. So what is happening here? Can we say that one pole is getting cancelled? And what is this? This is a 0, isn't it? So there is a 0 and a pole at the same location. That pole gets cancelled. And if there is a pole getting cancelled, then there is a possibility that the ROC may expand. Okay, and it may or may not expand, because suppose you consider a case like there are 3 poles. Suppose if it is a right-sided signal, this one. Now when you combine this with another signal, when you use the linearity property, there is a chance that one of these poles, one or more of these poles may get cancelled. Okay, suppose if this pole is getting cancelled, then will it affect the ROC? Now my point is, let's say there are 3 poles, like -1, -2, -3. So the expression is 1 by s plus 1 into s plus 2 into s plus 3. Let's say this one. Now, when you combine this with some other signal, and if it is a right-sided signal, what is the ROC? What is the ROC of this? If it is a right-sided signal, rightmost pole is at -1, real part of s greater than -1. What I am saying is, if you combine this with another signal, there is a possibility that one of these poles may get cancelled. That is what is happening here. When you combine these two, that operation introduces a 0 at s plus 1, and these two will get cancelled. And we call this a pole 0 cancellation. One pole is getting cancelled with a 0. So if one pole is cancelled, since ROC is bounded by poles, then there is a possibility that the ROC will expand. Okay, and that is what is happening here. That is why we use this notation. The corresponding ROC can be a superset of R1 intersection R2. Is it okay? Can it be less than this? Can it be a subset of R1 intersection R2? It cannot be a subset of R1 and intersection R2. The reason is that happens only if we introduce some new pole. But when you combine these two, that will not introduce any new pole. Only possibility is that it may introduce some 0, because the denominator you will get all these values only, nothing new will come. But in the numerator, there is a possibility that one pole by one or more zeros may be introduced, and some poles may get cancelled. That is why if there is a pole getting cancelled, before that cancellation, if it was the ROC was limited by that pole, that is what is happening in this case. Before this, when you consider these two individually and taking the intersection, the ROC was limited by this pole. Now, when a 0 is introduced, this pole gets cancelled, so the ROC expands. Okay, so this is linearity property. The ROC is R. It is a superset of R1 intersection R2. Okay. Any question regarding this? Okay, now let us discuss the second property. So remember, in all the properties, we'll be mainly discussing about the shape of the ROC, how the shape of the ROC changes. And in all the cases, you can easily understand that if you look at the property, whether a pole is introduced or whether it is getting cancelled, then only the ROC will change. If there is no new pole introduced, then the ROC will remain the same. Okay, so we will see that xt minus t naught, if xt, okay, let's say the time shifting property is that if xt Laplace transform is x of s and its ROC is r, then time shifting property says that xt minus t naught, it is similar to that of the Fourier transform. It is x of s into e to the power minus s t naught. Okay, it is in the case of Fourier transform, it was minus j omega t naught. Now it is s t naught. And let's say R1 is the ROC. What is the relation between R1 and R? What is the relation between R1 and R? Is it R1 is equal to R? So basically what you have to see is, first let us assume that this is a rational. It is easy to understand if we consider this as a rational transform. Xs is rational. Xs is rational means this is n of s divided by d of s, ratio of two polynomials. Now, if it is rational, its ROC is limited by poles. Now, if you multiply with, here what is happening is, if you delay in the time domain, you multiply with e to the power minus st naught. Will it introduce any new pole? New pole means what? There will be some term like s plus p1 or s plus p2. If you multiply with e to the power minus st naught, will it introduce any new pole? You are multiplying with e to the power minus st naught. Is it this form? Is it of this form? No. So there will not be any new pole. Is there any possibility of some pole getting cancelled? Is there any possibility? Because this is of this form. There is no pole. No pole will get cancelled, because for getting cancelled you have to introduce some zero. This will not introduce any zero. Okay. So that is why R1 is same as R. ROC will remain the same. Now the corresponding property in the frequency domain is, if you multiply with e to the power s naught t xt. I hope you remember the corresponding property in the corresponding property of Fourier transform. E to the power j omega naught t xt is x of j omega minus omega naught. So here also it is x of s minus n. And one more thing, you don't have to remember these properties. Everything is given in the formula sheet. Okay, I know it can be confusing. Even though they are similar, you don't have to remember this. It is given in the formula sheet that you can use in the exam. Tell me what will happen to the ROC. Suppose x of s ROC is R1. What will happen to the ROC? Will there be any change in the ROC? Will there be any change in the ROC? Remember, the shape of the ROC is determined by the poles. Is there any change in the location of the poles? Let us consider a simple case. Let's say x of s is in a simple form. This one. This is the Laplace transform. Okay. Where is the pole? Where is the pole? What is the pole of this function? What is the root?
P1.
It is at P1. This is a pole. Okay. So there is a pole at P1. So depending on whether it is a right-sided or left-sided, it can be either a right-sided signal or a left-sided signal. Forget about that. Now, if you multiply with e to the power s naught t, what will happen? Let's say this is x1s. What is that function x1s? What is the property? E to the power s naught t. So is this 1 by s minus s naught minus p1? Replace s with s minus s naught. S minus s naught. That is the property. Now tell me where is the pole of this function?
S naught plus P1.
It is s naught plus p1. Okay. So here, suppose earlier the pole was here. Where will be the new pole? It will be shifted depending on the value of s naught. And what is the nature of s naught? It is in general, it is a complex valued quantity, constant. So this pole may shift somewhere here. Okay. It depends on the value of s naught. There will be a shift in the pole. So this is the location of the pole of this function. Now tell me what is the corresponding shift in the ROC. Suppose R1 is the ROC of x of s. Tell me what is the ROC of x1s. How much will it be shifted? Suppose you consider s naught as, let's say, 2 plus it is a complex variable. I'm taking its value as 2 plus j1. So how much will this ROC be shifted? What is this location? Initially the pole is at here. Now it is shifted somewhere here. And this shift is how much? This one?
Real part of s naught.
It is real part of s. This will be shifted by, this is p1 plus 2. And this one? It is shifted by 1, isn't it? Imaginary part. Now tell me how much the ROC will shift. Suppose earlier this was a right-sided signal. If you multiply it with e to the power s naught t, it will also be a right-sided signal. That will not change because this is a two-sided signal. Now what will be the shape of the new ROC? Is it this? How much will be the shift?
2.
2. 2 is what?
Real
2 is,
part of S.
so can we generalize this? If R is the ROC of x of s, the ROC of this x of s minus s naught, that if we denote by R of R1, that is equal to R plus what? Real part of s naught? Is it? In this case, it will be, okay, remember, there can be a slight confusion here. Here we are talking about the sets. So this plus means this is shifted by this much amount. Okay, it is not, these are not constants. These are sets. We are talking about sets. So the entire set, that will be, so here in this case, the initial ROC was like this, P1. And when you add, when you multiply with e to the power s naught t, where s naught is 2 plus 1, then this will be shifted right. That is meant by this, R plus real part of s naught. There will be a shift in the ROC because the poles, the location of the poles will shift. Okay.